Kurnia Putri Tanjung from CISP 18. So we want to present our presentation, but the first will be presented by me. We will be discuss about atomic structure. So, the development of atomic theory, first founder, we must know who's the founder of this theory, right? So the first is Dalton. And you can see it on the slide, the faces of the founder. First, John Dalton. And the picture of the theory. John Dalton in 1808 put in this way. There are four parts. And the first, all matter has the smaller parts called atoms. The atom cannot be further divided into smaller parts. The atoms of an element are the same in all respects, but are different from the atoms of other elements. In the formation of compounds, bonds occur between the constituents of these compounds. The atoms are joined in simple proportion. All substances are composed of atoms which cannot be further divided into smaller parts. According to Dalton, atoms are solid dense balls. Elements are substances that are composed of the same atoms. The same atoms will have the same properties. Different atoms will have different properties. From the purple ball can be seen will have the same material, the same volume, and etc. While the red one will be different from the purple one. Compounds are substances that are composed of a combination of two or more atoms with a certain ratio. Like a water molecule has an H atom and O atom. A chemical reaction is the rearrangement of the atoms in a reactant into different combinations. Atoms cannot be created or destroyed in chemical reaction. Okay, for the second theory or the second founder, development of atomic theory is Thomson. And you can see the slide, the picture or the face of Thomson. And this is the picture of their theory about the atomic. Sir G.G. Thomson in 1897 showed the electron with his theory as follows two parts. First, atom is a ball with a positive charge. In certain places there are electrons that are negatively charged. And the second is the amount of positive charge equals negative charge. Atoms is a positive charge in which the electrons are spread evenly. This model is similar to resin bread, where the resin are electrons and the bread is a positive charge. The third founder of this theory, this development of atomic theory, is Rutherford. And this is the face or the picture of Rutherford. And this is the picture of their theory about the atomic. Ernest Rutherford in 1911 revealed the nuclear model for an atom. There are three parts. So first, atomic mass is centered on the atomic nucleus. You can see on the slide the picture. Second, electrons circulate around the nucleus in their orbits or cell. And the third, the atomic size is about 10 to the power minus 8 cm and the atomic nucleus 10 to the power minus 13 cm. Atomic mass isn't evenly distributed through the atomic volume but is collected in the nucleus of the atom nucleus. Almost 99.95% is in the nucleus while the rest is empty space. In the nucleus, the positive charge is scattered. On the other hand, the electrons rotate and circle the nucleus of the atom and form a trajectory. So we continue about the development of atomic theory. In the founder is Bohr. So this is the faces of Bohr and the picture of their theory about atomic. Niels Bohr in 1913 worked with Rutherford to modify the atomic model. There are two. The first, electrons surround the nucleus at specified energy levels called electron cells. And the second, electrons can move from one energy level to another by releasing or absorbing energy. Electrons rotate around the nucleus in a certain path without losing any energy at all, which is called a stationary path, so that the electrons can rotate forever in this path. Electrons can move in another path by absorbing or releasing protons. This theory is also called the planetary model. The last but not least is about the development of atomic theory is quantum mechanical. So this is the thesis of Louis de Broglie, said electrons are waves and particles. Then this is the picture or the face of Erwin Schrödinger, the wave equation for electrons in atom. And the third is Heisenberg, the principle of uncertainty by Werner Heisenberg. Okay, so this is the picture of this theory, electron in atoms. According to the atomic theory of quantum mechanics, electrons do not move in certain trajectories. Based on this, the quantum mechanical atomic model is as follows: three parts. On the first, the atom consists of an atomic nucleus containing protons and neutrons, and the electrons surrounding the atomic nucleus are in certain orbitals that make up the atomic cells. This is called the orbital concept. Second, Erwin Schrödinger formulated the concept of an orbital as a space in which an electron can be found. And the third, the position of the electron in the orbitals are expressed in quantum numbers. Electrons don't rotate in a definite path, but in a wave form, so they don't know the exact location of the electrons. These possible locations on the cloud are called orbitals. So all of this is a display of the fifth development of the atomic theory. Then we will be continue about the second theory or the second topic. That is atomic building particles. So this is the founder of this theory. The first is J.J. Thomson, second Eugen Goldstein, the third is Rutherford, and the fourth Bethe and Becker. The first we will be discuss about the electron. So what is it? So this is the case of William Crookes. The electron was discovered by Jobs John Thomson or J.J. Thomson in 1897. The discovery of the electron began with the discovery of the cathode tube by William Crookes. The William Crookes, you can see the faces of William Crookes on the slide. Then J.J. Thomson did further research on cathode rays. The properties of cathode rays include divided four parts. So the first, propagating perpendicularly from the cathode surface towards the anode. The second, there is a particle radiation, so that is proven to be able to rotate properly. Third, negatively charged, so that is deflected to a positive electric pole. And last but not least, can deflect various types of substances including glass. So this is the picture of J.J. Thomson when he found this theory. Okay, next this is the cathode ray tube, and I will put the picture. This is from the result of this experiment. J.J. Thomson stated that cathode rays are particles that make up the atom which is negatively charged, and hereinafter revert to as electrons. For more understand, I will be explain with this video. electrons are observed in a vacuum tube, which is a vacuum glass tube equipped with at least 2 metal electrodes that are given an electric voltage, a cathode or negative electrode, and another for positive electrode. The first electrons were found to be the building blocks of cathode rays. J.J. Thomson was able to determine the ratio between the charge to the mass of the electron. And Robert Millikan from the University of Chicago succeeded in determining the charge size of one electron. For the size and the mass, you can see on the slide. So this is the face or picture of Robert Millikan. And the value, the mass on one electron, you can see on the slide. And after the discovery of the electron, Dalton's atomic model became unacceptable. According to J.J. Thomson, the atom is a neutral particle. So this is the picture about the atom. Around the 1870s, scientists already understood cathode rays very well through several experiments. Cathode rays propagate straight, have mass, and are negative charge. Cathode rays are the movement of particles originating from the cathode. These particles are known as electrons. J.J. Thomson succeeded in calculating the charge and mass of the electrons. Robert Millikan conducted an oil drop experiment and he got the electrons' value. Okay, next is proton. The second we will discuss is about proton, and this is the faces or the picture of Eugene Goldstein, this founder. In 1886, Eugene Goldstein modified the cathode ray tube by perforating the cathode plate, and the gas behind the cathode plate became incandescent. This even indicates the presence of radiation coming from the anode through a hole in a cathode plate. These rays are called anode rays or positive rays. The properties of anode rays include 3. So the first is particle radiation so that it can rotate the propeller. The second is an electric or magnetic field deflected to the negative pole, so it is positively charged radiation. And the third, the anode ray particles depend on the type of gas in the tube. Okay. In 1910, Ernest Rutherford with two of his assistants, namely Hans Geiger and Ernest Marsden, they carry out a series of experiments to determine the position of the particles in the atom. Their experiment is known as alpha ray scattering on thin plates of gold. From their observation, it was found that the particles fired on thin gold metal plates were mostly transmitted, and some were bent and some even reflected. According to Marsden's observation, the fact is that 1 in 20,000 particles will bend in an angle in 90 degrees or more. Based on the Simpson, several conclusions were obtained, including 3 parts. So the first, the atom isn't a solid ball because almost all particles are passed off. That means most of the atomic volume is empty space. Second, particles that experience deflection are particles that approach the atomic nucleus. This is because both are positively charged. And the third, the reflected particles are those that hit the atomic nucleus precisely. Third topic is about neutron. So this is the founder of this theory. The first with W. Booth, the second is H. Becker, and the third is James Chadwick. In 1930, W. Booth and H. Baker conducted another experiment, namely shooting the nucleus of beryllium with particles, and they found a particle radiation that has a large penetrating power. Then, in 1932, James Chadwick proved that radiation consists of neutral particles whose mass is almost the same as the mass of protons. Because the particles are neutral, they are called neutrons. Thank you very much for listening and focus on my presentation. And I'm sorry of my mistake if I have a making mistakes. And I'm sorry for my condition is very noisy. And for the other presentation will be presented with my friends Mega Feronika Purba.
Hi, I am Mega Feronika Purba from Bilingual Chemistry 2018, and I will present to you about atomic number and mass number of atom. Okay, next let's talk about atomic number and mass number of atom. Atomic number. What is definition of atomic number? Every element has a unique number of proton in its atom, usually symbolized as Z. Because normally atoms are electrically neutral, the atomic number also specifies how many electrons an atom has. The lightest atom or hydrogen has an atomic number equal to 1, which contain 1 proton and 1 electron and electrically neutral. Okay, next slide. Mass number. What is the definition of mass number? The total number of proton and neutron in the nucleus of an atom is the mass number of atom, usually symbolized as A. The mass number of an atom is an approximation of the mass of the atom. This is because the electron mass in the atom can be neglected, the mass of proton and neutron, so the mass of atom is determined by the mass of proton and neutron in nucleus. Fast, right? Next slide. In its relation to the atomic number and mass number to the atom of an element is usually expressed by the following symbol: A, X, and Z, where X is the name of atom, A mass number of atom, and Z is atomic number. Z is number of proton, proton is same with electron, A is number of proton plus number of neutron, A minus Z is number of neutron. You can skip this video, skip this slide to make sure you understand, and you can observe this by yourself. In the next slide, I will put some example for you, and to make sure you understand. Next slide, sample problem test by yourself. Determine the number of proton, electron, and neutron for 168O199F. For number 1, I have give the solution, and number 2, solve by yourself. Don't forget comment below if you find the answer. Okay, I will read it. By yourself. Okay. Next, isotope, isobar, and isoton. Next, concept of isotope, isobar, and isoton. Before discussing the meaning of isotope, isobar, and isoton, it's better if you review at least the 3 components that are given in element. The symbol of an ordinary element is given together with the mass number and atomic number. The symbol of the element represents the number of proton and the number of neutron in an element. At the same time, it can also be seen the number of electrons contained in the element. Next slide. Definition. Isotope is one of 2 or more species of an element atom having the same atomic number but differ in mass number. Even isobar is an atom which comes from different element but has the number or the same mass number. Isoton is an atom which comes from different element but has same the number of neutron. You can skip and see the box below the definition I have prepared for you. Okay, if you like this video, don't forget to like and comment below. I think this is some material usually out in senior high school. You must usual for this because it usually out in an exam, right? But this can like Example, element X has 10 proton and 12 neutron, while element Y has a mass number of 24 and an atomic number 12. The two elements include element X has number of proton 10, number of neutron 12, element Y has mass number 24, atomic number is same with number of proton is 12, number of neutron is 24 minus 12 is 12. From the information obtained the number of neutron for element X is equal to number neutron of element Y. So it can criterion for isoton. So these two elements are yes, isoton. That's right. Next, relative atomic mass and relative molecular mass. Next slide. Relative atomic mass is the mass of an atom determined by comparing it with the standard atomic mass. Relative atomic mass, abbreviated as AR, then the formula for determining the relative atomic mass, or AR, is the ratio of the average mass of the element to 1/12 mass of C. Or in bahasa, AR unsur X itu sama dengan massa rata-rata satu atom unsur X per 1 SMA, di mana 1 SMA sama dengan massa satu atom karbon per 12. Next, example. The mass of atom element X is, you can read it, and I have prepared the solution. If you don't understand, you can pause this video. Next, relative molecular mass. Relative molecular mass is the ratio between the average mass of one molecule to 1/12 of the mass of one C atom. In one substance molecule consists of the constituent atom. For example, one CaOH2 molecule contains one calcium atom, two oxygen atom, and two hydrogen atom. The MR value can be calculated by the following formula. MR sama dengan sigma AR, jumlah dari AR elemen itu. Paham? Oke. Paham? Next slide. This is the example. You can pause this video and you can observe this. I think that's all about my video, and if you like, don't forget to like, comment, and subscribe. Okay, I think we will meet in the next video. Bye bye. Thank you for watching.